All right. So what we're gonna talk here is there are few things left in P5 that I did not finish on last Thursday, because we are like finish up quite fast here. So there are two components left in P5 that is not. Do you see my screen or?
Yeah. Oh, we can see
No,
you, but not your screen.
Yep. Sorry. Okay. Now you can see it.
I think it just started. So okay,
Yep,
yeah.
you just started. Yep. So we talked about rational expressions on last Thursday, but there are two other components that I did not went over. One is talking about the domain of an algebraic expression. So this is one of them that I did not go over. And the last component that we didn't went over in class is the complex fraction. Okay, so these are the two things that we will be going over in the Zoom today. So when you do your P5, the first few questions in P5 is talking about the domain of an algebraic expression. And then the last few questions in P5 is talking about complex fractions. So those are the two components we didn't finish. So let me go over this with you guys. This is kind of like actually lecturing. And then once you finish the lecturing on this component, we will be doing the review for the midterms. And if you do have any questions in your homework, I will be happy to help you with it. Again, this will go till like 2:30, 3 o'clock. Okay, so let's start with this domain of an algebraic expression. And some students ask me, are these two components will be in your midterm tomorrow? The answer is yes. So you will see this part, and you will see the complex fraction part. So let's talk. What is the domain of an algebraic expression? The set of real numbers for which an algebraic expression is defined, okay, is called the domain of the expression. Okay, two algebraic expressions are equivalent when they have the same domain and yield the same value of for all numbers in that domain. So let me tell you what is a domain is. Okay. So a domain is where you tell me what numbers, if you plug it in to this algebraic expression, it will make it defined. Define in this case means we get a number, you get an output, you get a value. Okay. So example in this case is we start out with like a polynomial sections like x plus 5. Okay. So this is an expression. So what x values can you plug in? You still can get a defined answer. Again, what is meaning of define means you can get a solution. Okay. So we can plug x is 1, we can plug x is 2, we can plug x is 3, we can plug x as half, we even can plug x as the square root. Yes, if you plug root 2 in here, you still get a defined answer, means your answer is root 2 plus 5. So a defined means that you still get a solution in this case. You can still plug in with negative answers, you can plug in zeros. So you notice that in this case, your domain for this for this equation here, or for this expression here, is going to be all real numbers. Now, what is the meaning when I say the domain is all real numbers? All real numbers in this case means any number will work for when you plug it in there, okay, for your x. So, so that will make this defined. Okay, so we have a little trick behind this. Okay, so any polynomial expressions, your domain in this case will be all real numbers. So no matter, I think you guys remember polynomials, right? Polynomials are like x cubed and x squared, and those are polynomials that you guys did in P4. So these are all polynomials that we've tried to factor. The domain in this case is all real numbers unless unless it is restrictedly specified. Okay. So I will tell you what is the meaning of this specifically restricted here. So this domain, this is considered a polynomial. This is a polynomial. So the domain is always all real numbers. This is a polynomial. Okay. Another example about polynomial here is like x4 minus 3x squared plus, let's say 2x minus 10. This is also a polynomial. Okay, so what is the domain of this polynomial? The domain for this polynomial is all real numbers. Okay. So make sure you guys know that. If there is no domain restrictions, your domain for the polynomials is all real numbers. Now, what is a domain restriction? A domain restriction means we do not want to take all the numbers that is being plugged in. So we will restrict the domain. So example in this case will be like x3 minus 2x plus 8. This is also a polynomial. So if I don't have a domain restriction, then your domain in this case is all real numbers. But here is the domain restriction. X has to be greater than 1. So this is what I call this as your domain restriction. So what is the domain restriction in this case is it telling us we will take any number that is only above 1. Okay, that means we don't take zeros, we don't take negative numbers. So this is domain restriction here. So what is the domain for this polynomial? Then it will follow the domain restriction here, which is x is greater than 1. Or in other words, is 1 to infinity. Okay, so there are a few ways for you to write your domain answer. One way is just write it as an inequality if you have a domain restriction like this. Another way is to write this interval notation, which you learned in the first P1. Remember, this is 1 and then it goes to infinity. So that's why your domain in this case is from 1 to infinity, or x is greater than 1. So I do not know what your online homework will take. I think they want this as, I think it's x greater than 1. Let me check with you guys back once I finish doing this. So this is considered the domain restriction. Again, without this domain restriction, then your answer will be all real numbers. Okay, if you just take this part. This class, what I'm teaching here is also very important because we'll be doing a lot of domain in not just this class. You will talk about domain in college algebra, tricks, and also in calculus. Okay, so this is the domain for the polynomials. Now, what happens if I change the domain to a radical expression? So what is a radical expression? A radical expression means it's a root. Okay, so if you have a square root, a fourth root, fifth, a sixth root, then the domain in this case is make sure that your radicand is not negative. Okay, so we mentioned about that in when we do the radicals. Okay, so when we have a radical, okay, we talk about if you have an even index like square root, fourth root, fifth root, sixth root, eighth root, that in even here. Okay, I just put even. If your radicand is a negative numbers, you say this is DNE. Okay, we did this a lot in your calculator, right? However, if this is an odd root or odd index, if you have a negative, then your answer in this case is a negative number. Okay, so this is what we mentioned this in P2. So now we will talk about this for the domain case. Okay, so for the domain case, if you have a root and if this root is an even root, then what you need to do is you take the radicand. You guys know what a radicand is, the one inside here. You take the radicand, so your domain in this case will be your radicand has to be greater than or equals to 0. Okay. The reason why we need a radicand to be greater than or equal to 0 is because if you greater than or equal to 0 means it's positive. Okay, so that means that this number here has to be positive. Okay, Example in this case, we'll talk about examples. Let's say we do square root of x minus 4. So the domain in this case is you take the radicand and make it greater than or equals to 0. And the reason why we do this is because the number that is only allowed to be in here is either positive numbers or 0. So that's why we use this inequalities. So when you solve these inequalities, means you have to add 4 in here. So x is greater than or equals to 4. So this is the domain for this inequality here. What does that mean here is you can only put 4, 5, 6, 7, 8 all the way to infinity. Then your domain will work here. So what I'm trying to show you here is, so let's say you put 4 here. You find out that you get a 0. So you get 0. So this is work. When you plug 5 here, you get 1 because 5 minus 4 is 1, which is 1. So this is work. So all this domain is working. However, and then you continue plug 6 and 7, which is square root of 2. Square root of 2 also works. Square root of 2 is a number. However, if you put any number that is not in this from 4 to infinity, not in this domain, so let's say you plug 3 in here, what do you notice is you get a negative 1 because 3 minus 4 is negative 1. This is DNE. So that's the reason why that. And again, when you plug 2, anything that is lower than 4, so 3, 2, 1, negative 0, you find out this below is going to be a negative numbers, and we know that that will be DNE here. So that's the reason why that the domain for a even root, like square root, 4th root, 6th root, is you take the radicand and you make it greater than or equals to 0. Okay, so this is kind of domain that we have here. Now this is only for even root. What happens if you have an odd root? Now, as you know that in odd root, like cube root and 5th root and 7th root, we still get a number here, so we don't need to worry about it. So what happens when your domain is for the odd root? Then your answer in this case will be all real numbers. Okay, so example in this case is like, what is the domain for cube root of x squared minus 4, example. This domain will, the domain for this will be all real numbers. Okay, that means any numbers you plug in here, it will work. You can plug x is 0, x is 1, x is 2, x is 4, 5, negative 1. Any number here, your this expression will work in this case because it is a cube root, okay, or a 5th root or any root. So this is the domain for the roots in this case. Okay, so this is also very important, class. What I'm teaching you here is very, very important. We talk about domain a lot coming up here. Okay, so this is for the radical. What happens when you get yourself a rational expression? So what is a rational expression? Rational expression is the one that looks like a root. Okay, so for the fraction. Okay, so when you have a radical expression, your domain for the radical expression in this case is it's a set of all real numbers, except when you divide your denominator, your division is by 0, or in other words, your denominator is 0, which will be undefined in this case. So for the, save this so you guys will, yes, I'm going to post everything here in D2L, so you will get a copy of this. So you can review this. So so what is a rational expression? The rational expression is like fraction, like 3x minus 2 over by x minus 5. So this is a rational expression. So we need to figure out what is the domain in this case. So the domain in this case is set of all real numbers except your denominator cannot be 0 because we cannot divide by 0. So what we do to find the domain here is you set your denominator equals to 0. Again, we don't care about your numerator because your numerator is 0, is still divisible. However, if your denominator is 0, you get undefined. So we will solve this. So you get x equals to 5. So then your domain in this case will be all real numbers except x equals to 5. So what is your domain for this kind means that any number will work in this case. The only number that doesn't work is 5, because when you plug 5 in here, you will get exactly 0 in your denominator. And as you know that anything divided by 0, you will get undefined. So that's why the domain here does not work, because the domain in this case says that it has to be defined. The expression has to be defined. But unfortunately, when you get 0 in this case, it is undefined. So that's why it is not what we want. So the domain for a rational expression is very easy. You just take your denominator equals to 0 and you solve for it. Okay, and then you put all real numbers except the number that you found when you solve your denominator. So this is how we do the domain piece here. Okay, so we do some quick example in this case. Okay, so the first example is asking us is what is the domain for this expression? Now, for the first one, we know this is what we call as a polynomial. Okay, usually polynomials, the domain is all real numbers. Okay, this is a polynomial. However, this polynomial has a domain restriction. So this is the domain restriction. So the domain restriction usually given to us once you see a comma and after that. So this is what we call as your domain restriction. Okay, so that domain restriction will tell us that we only can use this domain. So for this question, your domain in this case will be x is greater than or equals to 0. Okay, again, I don't have the symbol greater than or equals in my keyboard, so I'm using this for that. So make sure you guys know this. This is very, very important. Okay, so without this domain restriction, your answer is all real numbers. But with the domain restriction, so I'm going to gently scratch this fellow off. Okay, with that, our domain in this case will be x is greater than 0. You can write in this way, or you can give it to me as bracket 0 to infinity in parentheses. Again, I don't have an infinity symbols. I will use INF for the infinity symbols. So there are two ways to write this domain. I'm not very picky how you write this. You can write this way or that way. I'm okay with it as long as you know how to figure out your domain here. Next, this is a radical expression. So when we have a radical, it's called a radical expression. We will look for your roots, and this is actually an even root, which is a square root here. Okay, so when you have an even root, so how do you find your domain in this case? You take the radicand, which is x plus 7, and you make it s greater than or equals to 0. And you solve for x here. So I subtract 7 on both sides. So x in this case is greater than or equals to -7. So this is your domain in this case. That means any number from -7 and above will make this positive. Okay, so your domain for this case is x is greater than or equals to -7. Or if you want, you can write this as -7 to infinity, if you want to put it in an interval notation. So this is the domain for this question 2. For question 3, we call this as your rational expression. Okay. The reason why this is rational expression is because it is fraction. Okay. So how do you figure out your domain in this case? Your domain is all real numbers except what makes the your denominator become 0. So in this case, we just need to set your denominator become 0 and we solve for x. Now, the good news for this question 3 is you do not need to solve it because it's already x by itself. So your domain in this case will be all real numbers except x equals to 0. So this is how we do your domain in this case is all real numbers except your denominator is 0. So what is it telling us is any numbers you can plug in x, you still get a defined answer, means you still get a solution. The only answers that you will get undefined or not, you cannot find a solution is when x is 0. In this case, your denominator is 0. So this is how you figure out your domain in this case. So these are how we figure out these domains. And later on, when you guys continue with the P1, the chapter 1 works, you will do the domain for that case too. So just learn how a little bit of domain. So let's take a look at your homework for this P5 here. So there are a few homeworks that you need to worry about. There are 3 homeworks that's due. So I would highly recommend you to do your homework hopefully before your test by tomorrow. So example will be like question number 4. You need to find the domain of this expression. So can someone here tell me, is this expression that you see here, are they polynomial, radical, or rational? Question 4. Anyone?
Would it be polynomial?
Yes, this is a polynomial. And as I return, what is the domain of a polynomial? The domain of the polynomial is what?
All real numbers.
All real numbers. So despite we don't have a domain restriction here. So that's why your answer in this case will be all real numbers.
The domain restriction is the greater or less than 1
Yep.
symbol?
So anything behind the polynomial, which is like number 5. So the one I highlight in blue, that is the domain restriction.
Okay.
Okay. So what is the domain for question 5?
That'd be x less than, no, wait a minute. That's x greater than 0?
But you tell, so your domain in this case is x is greater than 0. Yep, that's correct. But you can tell that there's no x is greater than 0 in your choices here. Can someone tell me what's the meaning when I say x is greater than 0?
Just the all real numbers above 0.
And what does that mean when you say all real numbers above 0? Can you tell me, is that all real numbers, positive real numbers? Which one? A, B, C?
Oh, which
C?
answer? Give me a second.
Yep. So what is your answer here? Yep. X is greater than 0 is your answer, but unfortunately we don't have that choice, right? So what does that mean when we say x is greater than 0?
All positive real numbers?
Yes, this is all positive real numbers, means that greater than 0 means any number that is above 0. Above 0 means they are positive numbers. So that means all positive real numbers is what you're looking for. But in a test, if you just give me x greater than 0, I still take it as your answer. I still mark it right. Okay.
You said there's no word problems, right?
No, this is not word problem. This is just finding the domain.
Oh, I just wanted to make sure regardless.
We don't have any word problems in your test. Next, can someone tell me what is this expression is? Is this expression polynomial, the point number 6, radical, or rational expression?
Rational.
So this is a rational because it's a fraction. And what do I mention about the rational is all real numbers except make any number will make your denominator become 0, right? So can someone solve for your denominator for me? Solve your denominator. 5x plus 3, and you make it equals to 0.
Would it be all real numbers?
No, we still need to solve this first.
Okay, never mind.
Now you have to solve your denominator first before you do that, and you will get your answers popping up here. So anyone got an answer here? You guys know how to solve this? So you minus 3. So you get 5x equals to negative 3. And then you divide both sides by what? By 5. So your solving for this is x equals to negative 3 over 5. So what is your domain in this case? You'll be all real numbers except what?
Negative 3/5.
Negative 3/5. So which one is your answer in this case? A, B, C, D, and or E. This will be the D part. Okay. Question 7 is the same, very similar type. So what you need to do, class, is to set your denominator equals to 0, and you solve for x. Now, once you solve for x, then your answer is all real numbers except that whatever x value you get. Okay. So these two are what we call as your rational expression, and that's how we figure out your domain in this case. How about question 8? So question 8, what we call this?
Radical expression.
This is called a radical expression. And so in order for us to do the radical expression, you have to look at your roots. And since this is an even root, which is a square root, so how do we figure out your domain? Is you take the radicand and make it greater than and equals to 0 and solve for x. So this is how you figure out your this is question number 6, I believe. This is question number 8. So how do we figure out your domain for this case? Is you take your radicand, because it's a radical, square root in this case, 7 minus x, and you make it greater than or equal to 0. And you have to solve for x here. So how do we solve for x in this case? We did the same thing as solving equations. So we will minus 7 on both sides. And then we have a negative x is greater than or equals to negative 7. And then now we need to get rid of this negative. So I will divide this with negative 1. Now, this is very important. I know you guys remember this from your high school when you take your math, your algebra class. When you divide or multiply with a negative number, your inequality, if you're doing inequalities, your inequality has to be switched around. So this is very, very important. So make sure you guys know this. This is one of the important rules when you divide, when you multiply or divide with the negative numbers for inequalities. So you got x here, and you got 7 because negative 7 divided by negative 1 is 7. So your answer in this case is all real numbers satisfying x is less than or equals to 7. So that answer is B in this case. So this is how we do question number 8. Again, in the test, you do not need to write all real numbers x satisfying x is less than or equal to 7. So your answer in your, if I come up this question in your midterm tomorrow, then your answer in this case, you just give it to me as x is less than or equal to 7. That is good enough. You do not need to do all the writing all real numbers and so on. Okay. The only time that you need to put all real numbers is when you have what? A rational expression. Then you need to give me all real numbers except something. Okay. So for the rest of it, you just give me x is greater than less, a number in this case. Okay. So very straightforward type questions here. So this is how we do question 8. Anyone have any questions for me? The last one is question 9. This is finding the domain for this question. Now, this one is a special case. Why I say number 9 is a special case is because it consists of a radical and it is also a rational. This is actually a radical rational expression. A radical is because it has a root. Rational means it is a fraction. So when you have a radical and rational together, like this case, we will concentrate more on both the square root and your denominator. So as you know that this square root is in your denominator, so your domain in this case will be taking your radicand greater than 0. Now, last time, if you look at question 8, we take the radicand greater than or equals to 0. But for question 9, we just need to take the radicand greater than 0. The reason why we cannot put equal here is because if you do this exactly 0, then you will also get an undefined situation because 1 over 0 is undefined. So we will try not to have equal to symbol. Okay, so that is the difference between question 8 and question 9. So the radicand in this case is x plus 8. So you just take the radicand, which is x plus 8 in this case, make it greater than 0. Again, we subtract 8. So you find out that x in this case is greater than -8. So this is your domain in this case, which is x is greater than -8. That will be C in this case. Okay. So this is how we do this question. But again, do not need to worry about like question number 9 here. Mostly in your test is either I give you a radical, a rational, or a rational. If I give you a polynomial, usually I will give you a domain restriction in this case. So it's very similar to your notes that we go over here. So this is the 3 types of questions that one of them will be coming up in your test here, in your midterm tomorrow. So make sure you guys know how to figure out your domain in this case. Questions, students, before we continue with the second part of it? The next part we have is what we call as a complex fraction. Save this. So what is a complex fraction in this case? A complex fraction is a fraction expression with separate fractions in the numerator, denominator, or both. So another meaning when I say complex fraction is fractions on fractions. Okay. So examples of a complex fractions will be like you got a fraction, a rational, so something like this. And then you have over by another polynomial, let's say. So this is what we call as a complex fraction. And I just want to point out to you that make sure you look at the question, the complex fraction very carefully. The longer the line is, means that this is your top, this is your numerator, and this is your denominator. Okay, just want to point out to you guys. It can be this way. So you have to watch out which one is longer, the line. Okay. So if I write it this way, then this is not the same as the example that we just used here. It's because your numerator here is just 3x minus 2, but your denominator is x plus 3 over x plus 5. It's different. So these two are not the same. Okay, just want to point out to you guys that, but they are called complex fraction. Again, what is complex fractions is fraction over by fraction. And another type of complex fractions that we have here is something like this. So we got this, and then we got another fractions down here. So this is also a complex fraction. Okay. So again, the top one is your numerator, the bottom one is a denominator. Okay. So how do we do this type of complex fraction? How do we simplify this? There are two methods, but today class, I've only shown you one method. So the other methods, I'm not going to show it to you. So again, there are two methods to simplify this kind of fraction. So first, I'm going to do method one, which is the one that I will strongly suggest students to be good at this, because if I introduce two methods, then you guys will get confused. Okay. So when you do your online homework, you say, please use method one, please use method two. Just ignore it. Just use everything in the method one in this case. Okay. So how do we do this? So we'll just, I will show it to you. I just use numbers so you guys can, so you guys know what to do with. So, so how do we do like this kind of complex fraction is, this is your numerator, so it's 1/3. So for method one is you just simply write this division as the divide symbol, and then you put the 5 over here. Okay, so this is usually the method one is you simply write the division symbol into the divide symbol. And then this is something that you guys been doing this. So you just need to change this divide to become multiply, and then you flip the fraction in the back. So it's 1/5. And then you multiply them straight across. This is 1/15. So this is how we do, how we simplify complex fraction is we take that long division sign or put it as a divide. And then the one in the denominator, you just put it next to it. And then you change the division sign to become multiplier sign. And then you flip flop it. Okay. Same thing happens if I give you something like this. 6/7 over by 8/3, example. So what you do in this case is you take 6/7, and this long division sign you just replace with divide, and then you got 8/3. And what we do next is change this division to become multiplication, and you flip it. Now we need to multiply this. Now, because they can be reduced, so we can reduce first, which will be easier for us. How do we reduce this? Is write this in the factor form. This is something we did on Thursday's class. So 6 in this case is 2 times 3. Now 7, you cannot write this in the factor form because 7 is only 1 times 7. Okay. Same thing happens to the 3. 3 in this case is just 1 times 3, so we cannot reduce. We cannot write this in the factor form. But 8 is 2 times 4. And 4 can be written down as 2 times 2. So this is your factor form. And then you just cancel. So we only managed to cancel one of the 2's here. So again, you multiply them straight across. This will give us 9. And this will give us 28, which is 7 times 4. So your answer in this case will be 9 over 28. So this is kind of what we do in the method one. First, write the long division sign. You change that to become divide. And then your fraction, your denominator will be, you divide with the denominator. So this is a numerator. So this is what you need to do first, is write your numerator divided by your denominator. And then after that, you change the division sign to become multiple sign. And then you put, you flip it. Okay, you flip your denominator. And then what we do next is you have to factor this. And then if you have any common factors, you cancel it. So this is what we do for this kind of complex fraction. So it's not that difficult. Okay, it looks difficult, but it is actually is not that difficult. Okay, let me save this. Complex fraction. So we look at some examples here, so you guys will see it. So this is the last two questions here. Question number 10 and 11. So this is 1 over x plus 2. I don't know why I put parentheses on it. Should not write parentheses on it. Plus 1 over by x over 3 minus 1. Okay. Now, when you begin to add and subtract this, we have to make them as one whole single fraction. So what we do in this case is we have to kind of, before we continue doing this, I need to change it back that way. Let me go back to, let me save this and then I will change it back to the rules here. Sorry about that. The hidden over here. Okay, so so this is what happens if they all are nicely done. There's no addition and subtraction. But what happens when they have addition and subtraction? Then you have to perform. You have to make them as what we call as a single fraction here. So you have to find the LCD. Okay, so let me give you another. So if you have addition or subtraction, you have to find LCD in this case before you start doing 1, 2, and 3. Okay, so I will show you what does that mean here. Okay, so for example, in this case is, let's say I use number again, 1 over 4 plus 2 over 5 divided by 1 over 3 minus 2. So if you have like addition and subtraction, so what do we do in this case, class, is we will add and subtract. So we concentrate on the top one first, and you find what is the LCD for this case. And the LCD in this case is 20, because 4 times 5 is 20. So again, we multiply this by 5, and we'll multiply this by 4. So we make them kind of the same LCD. And then the top one here is going to be 5 plus 8. So that will give us 13 over 20. And then you repeat the same thing in your denominator. So this is over 1. Don't forget, you can always make this over 1 if they're not in that fraction. So you find the LCD for the denominator one. And the LCD in this case will be 3, because it's 1 times 3 or 3 times 1. So this is already 3, so we do not need to do anything. But this one we need to multiply by 3 to give us 6. So this will give me negative 5 over 3. So this is where I mentioned that if you got them into what we call as a single fractions over by single fractions. Originally, you got 2 over, you don't have a single fraction here due to the positive or the minus sign. So once you get them into the single fractions, then you can do what I just mentioned here is you take the numerator, you divide this, because this division is divided by your denominator. And then what you do is you just change the division to become multiply. And then you flip the next, you flip the second fraction. And then you simplify this. 13, you cannot write anything. So 13 is a prime, so it's become by itself. 20 is 5 times 4, but 4 can be written down as 2 times 2. So 20 is 5 times 2 times 2. 3 is -3 because it cannot do anything. 5 is just 5 because they are also prime. So you notice that for this kind of questions, there is nothing you can cancel because there's nothing in common between the top or the numerator and the denominator. So you just multiply them straight across. So this is -39 over by 100. So this is your answer. So again, what we do here, class, is we find the LCD. If they have like addition and subtraction, you find the LCD for the top one and you perform it like, add and subtract. And then you find the LCD on the bottom one and you do the same thing. And then now you get yourself what we call as a single fraction. Okay. And once you get a single fractions on the top and the bottom, and you will begin to do what I just teach you here, change the division sign into divide, and then flip then your denominator on the other side, and then flip your denominator, change to multiply, and then you simplify. So this is kind of how we do this kind of questions here. So I should need to I just do 2 here, and then so this is how we. So let's take a look at this question number 10 here. So we got 1 over x plus 2 plus 1 over by x minus 3, x over 3 minus 1. So this is the complex fraction for question 10. So, so what we need to do for this kind of question is we have to make this as a single fraction. So again, let's concentrate on the numerator. So make it over 1. And you found what is the LCD in this case. So since this one cannot be factored, x plus 2 cannot be factored. So there is no common factor in this case. So there's no common denominator. There are 2 different things. So your common denominator in this case will be x plus 2. So what we need to do here is we will multiply this by x plus 2. We do not need to multiply the first one. The reason why is because it is already x plus 2. So what we have in this case is your denominator is x plus 2. But your numerator, you just need to do some distributive. So the first one is 1 plus 1 times x is x. 1 times 2 is 2. And you just combine this. So you get x plus 3, combine like terms, over by x plus 2. So this is how we do the top part. And now we will do the denominator part. And again, this is over 1. So these are numbers. So your LCD in this case will be 3. So this is over 3. Again, the first one, we do not need to multiply anything because it's already 3. So this one, we need to multiply by 3. So we have this x minus 3. So this is going to be x plus 3 over x plus 2 all over by x minus 3 over 3. So this is coming from the red one is from the numerator and the purple one is coming from the denominator. So now what we need to do is we flip them. So we do the numerator part, x plus 3 over x plus 2. And then we will change the division into the divide. And then we have the x minus 3 over 3. And then what we do is we change the division symbol to become multiplying symbol, but you have to flip him up. Okay, flip the second one. And now you look at if you can factor this. Unfortunately, x plus 3 cannot be factored because you don't see any square or cube, and there's no GCF. X plus 2 also cannot be factored because it is no squaring here and there's no GCF. 3 cannot be factored because it's a prime, and x minus 3 is not factored. So none of this is factorable. If they're not factorable, then let's see if we can cancel them. Unfortunately, we cannot cancel them because this is x plus 3, this is x minus 2. They are not the same. So your answer in this case will be 3 times x plus 3, the whole thing, that we cannot cancel it. And do not distribute or FOIL, leave it as the factor form, we call it x plus 2 and x minus 3 in the denominator. So this is your answer for question number 10. If they can be canceled, then you cancel it, okay? Unless if they cannot be canceled, that is the end of it, okay? So this is how we do complex fraction, okay? How we simplify complex fraction. We got one more example here. 2 over x minus 3 divided by 1 minus 1 over x minus 1. Again, this is from your notes, so we'll do this together. So again, what we need to do here, class, is to find the LCD. So this 3 is over 1. So the LCD in this case is going to be x for the top, the numerator one, because that is x times 1. In this case is x. So your LCD here will be x. Now the first one is still 2 because we do not need to multiply anything here. But this you need to multiply by x, so you will get a minus 3x. So this is how we do the numerator. Now we do the denominator. So this is over 1. So that LCD for this case, again, I put it right down here, for the denominator is going to be x minus 1 because it's 1 times x minus 1. So what we need to do here is that is your x minus 1 here. And because this doesn't have x minus 1, so we will multiply this by x minus 1. So we kind of distribute this one. So 1 times x is x. 1 times negative 1 is negative 1. And you still have a minus 1 on the second fraction. So multiply this, will get x minus 1. And you still have a minus 1. So this is actually will give me x minus 2 over x minus 1. Again, your numerator here will become still 2 minus 3x over x. And now we will have to divide this. Don't forget, we have to divide all this. So this is back to what we just did over here. So you take your numerator, you divide with your denominator. So this is something you guys can do in my test, which is short form. But we know that you can change the division symbol to become multiply symbol. And what you need to do with your denominator is you flip it. So it's x minus 1 over x minus 2. So this is how you can still do the same thing I just did question 10, but this will be a fastest way to do it. And then now you try to factor this, and then after that, cancel common terms. Again, 2 minus 3x cannot be factorable. X cannot be factorable, and none of this is factorable is because they all are power 1, and there's no GCF. And also, they are not in common, so nothing in common here, so you cannot cancel anything. So your answer in this case will be 2 minus 3x, x minus 1, again, just multiply them. And then on the denominator, you get x minus times x minus 2. So this is your answer for question number 11. Anyone have any questions here for me? Yep, Kareem. Yep.
Yeah, I'm understanding this, but I'm still not quite getting maybe fast enough how you are getting to the third part. I have all of the rest of it, you know, where you got the second part once you find the LCD and all that.
Mm-hmm.
So are we using the same formula each time?
Mm-hmm.
Same.
Yep, the same step. Find the LCD for the numerator, and then find the LCD for the denominator. And then, find the LCD, and then you perform, the combine, like the same LCDs, and then, fraction, add them up, subtract them up. Do the same
Okay.
thing in the denominator, and then after that, change the divide into the division symbol, and then flip it. It's the same kind of pattern.
Okay.
It cannot be run away from. I mean, the steps is always the same steps. You cannot run away from the steps. And this is method one. Again, there are two ways to do this one, right? I'm just showing you the first method, which will be a bit more easier for you guys to see it. I don't want to get too confused with that. We can look for some, yep. So it's very similar to like this type of questions, you know. The only thing is that you have to convert them into the LCD first. We can take a look at like question number, let's do question number 24. We have x squared minus 25 over x over by x minus 5 squared over x. Now, this question 24, you do not need to find LCD on that. So why this one, we do not need to find LCD, but then when you do question number 10 and 11 here, this you have to find LCD. So anyone know why this two question you need to find LCD, right? Like we did, but not 24.
Because you're subtracting and adding on divisions.
Yep, that's correct. The reason why we find LCD here is we are subtracting and adding here, okay, or subtracting and subtract. Doesn't matter if add or subtract. But if you look carefully here, we also have adding and subtracting here. But this adding and subtracting is on the whole, okay? So it's not like partially. When I say partially, it will be something like, this is called partially, means this one is not the whole thing over, okay? So once you get like number 24 here, you can straight change this to become division. But the division, we can actually change it to become multiply. Then what you need to do with this is we flip it. So become x over by x minus 5 squared. Next thing we need to do here is we factor them. Now this time we can factor x squared minus 25. What's the factor for it? It's a perfect squares with a negative. What's the factor for this one?
X minus 5.
And also?
X plus 5.
Yep, the conjugate, yep. And then the denominator is still x because you cannot factor that below. This x is still x, cannot be factorable. And this one will become x minus 5 and an x minus 5 because square means you just duplicate that twice. So now we can cancel this. The x minus 5 can be canceled with one of this. The x can be canceled. So the leftover is your answer. So the x plus 5 over by x minus 5. So this is your answer in this case. So make sure you guys understand. Now, question number 23, you need to find the LCD because this 9 here is not over the whole thing. Okay, like here you see they're over. Okay, so if we are not over the whole thing, you need to find the LCD in this case. So there's only 2. Oh, I thought there's more than that. So make sure you guys know how do you find your do your complex fraction here. It's quite important. This is the end of the class here. So we start to do some revision and we also will do some questions here. Does anyone here has any homework questions? Anyone has any homework questions here? P3, P4, P5, anyone? Anyone has any homework questions?
Yes, I do. I was trying to unmute.
Yep.
So let me get to it. I do. I am on.
We'll do a couple of those and then we'll start doing the review for your test.
Well, actually, I'd rather just get to the review for the test, so never mind.
Okay. All right. So we'll do review for the midterms here. And then after that, we will concentrate more on, then after, if you have time, we'll do the homework, the online homework. As I mentioned, the review for the midterm is more important, right? Than the review for the test, for the homework. Your homework is important too, but this is like, you know, the most points given. So that's why I really want you to concentrate on this one. Anyone needs help for the first 4 questions?
Could you just do number 2 to make sure that I got it right? Because my end answer was 48m to the 3rd power over n to the 2nd power. That was my end answer. So I just wanted to make sure I did it right.
Okay. So can you tell me how you get that answer?
Well, here, I'm gonna turn on my my camera and show you.
Don't need to. No need to turn it on. Yep, Amy, I will give
Okay.
someone 4 here.
Did you want me to just explain it or?
Yep, just explain it how you get this.
Well, I switched over n to negative 2nd power to the bottom, and then brought 12m to 3rd power to the top.
That would be wrong.
That would be wrong. Am I only supposed to move up the m to the 3rd power and leave the 12 down there?
Yes, because
Okay.
your -3 here is only affecting the m, not the 12.
Okay, got it.
This is the one that you didn't move up. So that means your 4 and the 12 still remains where?
On the top and the bottom, yeah.
Yes. So because the 4 here is still a positive power, your 12 is still a positive power, we do not want to move them around. Your M3 is still going to be on the top here. Because these are all positive exponents, we do not want to switch them. The only thing that you switch is these 2, because this will become N2, become the bottom. And M-3 will move it to the top.
Do we just cancel out that n to the 0 power because that becomes 1, right?
You can, yeah, right? Because this is actually 1. N to the power 0 is 1. And anything multiplied by 1, we get back the same thing. So this is actually redundant. So you can cancel it off.
Okay, thank you.
Now you can do this. So so this is a fraction, so we have to reduce it. So what is the reduce of the fraction? (412). What's the reduce of 412?
Wouldn't that be 1/3? Yeah.
Okay. This is the same base. So what you do when you multiply, what you're gonna do with your exponents? They are multiplied.
Add them.
Yep, you gotta add them. So this is m to the power of what?
6.
And then you still have n squared at the bottom.
Right.
So this is your answer for question 2. Again, if you want the 1, it's up to you. You want to put it there, you don't want to put it there, it doesn't matter with me. Yep, you add them, yep. So this is your answer for question 2. Okay, let's look back at question 1. -4a squared times 6a to the 4. Oh, by the way, class, is this the only way to do this kind of questions? The answer is no. There are a lot of ways to do this kind of questions, but your answer is only one answer, which is that answer. Okay, so there are multiple ways. I got students doing, another way to do it. As long as you get the same answer, you're good. Okay, let's go back to question 1 here. By the way, I want you to read the question before we continue. It says to simplify each expression and then write your answer in positive exponents. That's why when you look at this, we are done here is because all your exponents are positive. So you do not need to worry about doing that because you really move your negative exponents. You take care of the negative exponents. This is something that very good. How you do question number 1? Now, there are few ways to do it. One way I will do it this way. Some students like it this way. The square here stands for you just need to duplicate this twice, right? So you take negative 4a times with negative 4a, because square means twice. And then you multiply this with 6a4, because that one doesn't have a power on it, like the number outside here. And what you do with this kind of question is for numbers, we multiply them. For exponents, we will add them because they are multiplying. Okay. So what we do with the numbers, we multiply. So you take negative 4 times with negative 4 times with 6. Those are the numbers, so we will multiply them. So what is negative 4 times negative 4? That is 16, positive 16. And what is positive 16 times 6? Use my calculator. There you go. So 16 times 6.
96.
It'll be 96. And then for the exponents, we add them. So we got a to the power of 1. Don't forget that's a 1. Plus another 1, because of the 1 here. And then plus another 4, because we got 4 in that case. So in this case, you get a total of a 6. So what is your answer in this case? Your answer for this case, I'm going to put it green, is 96 A6. So this is one way to do this question. Another way, if you want to do it, there are a lot of ways to do this. I will recommend you to do this way, because if you like to, because chances of you making mistakes on the way that I showed you is a bit small. Other way that you want to do this is you distribute. Okay, because we do have properties for exponents that if you have a power, you can distribute this. Now, don't forget that they're all having power 1 here. So when you distribute, you will get a negative 4 to the power of 2. Now, this requires you to have a parenthesis because they're all inside the parenthesis. So when you distribute, the negative is a part of your squaring. So that's why you have to parenthesize it. And then you got a squared. And then you still have the 6a4 that we will talk about later on. Okay. So let's do this distributing. So negative 4 times negative 4, you get 16a squared. And what we do here is we take 16a squared times with 6a4. And we repeat the same thing that what we just did here. Numbers we multiply, exponents we add. So numbers is 16 and 16. So we will multiply the number 16 times 16. That will give us 96. And exponents we add 2 and 4. When you add, this will become 6. So this is your answer. Again, you still get back the same answer. Again, class, as I mentioned, lots of ways to do these questions, right? But there are only one answer in this case. All right. Anyone? Let's move on to the next one. So if we have time, we'll go through the rest. How about doing 5, 6, 7, 8 of this page? You guys know how to do those? Okay, looks like it's good. Now we're going to talk about this. This is a bit more difficult. 9 till 14 here. Again, read the instruction. So the instruction says that you have to simplify each expression, assuming that all the variables are positive. When you see this, means that you do not need to worry about the absolute value. So anyone have any questions on 9 till 14?
I didn't really know how to approach 11.
11, okay.
Mm.
Beside 11.
Would I be correct in answering number 9 is not a real number?
Yes.
Okay, cool.
Or no
Thank you.
solution or DNE. I take all those numbers. I take all those answers. As long as you don't give me a number or something else. Yep. 9 is, so is that Brian, right?
Yeah.
Why you say this is DNE or not a real numbers or no solution? Can you tell?
Because there's no way to break down -72 in what's it called? 4 with the index of 4, I guess.
Yes.
If there's
Yep.
no better way of putting it.
This is same as the domain we mentioned early on because it is an even index. So your radicand cannot be what? Cannot be negative. Okay, so that's the reason why number 9 here is DNE or no real solution. Okay. Let's talk about question 11. So this is multiplying, right? Because it's this times this. There's no addition or subtraction. This is multiplying. So this is a foiling way to do it. But if you look carefully on this, they are actually conjugate. You guys know what conjugate means? It looks exactly the same, but one is plus and one is minus. Do you know what happens when you foil a conjugate? What happens to the middle terms?
They don't really matter, do they?
Yep. So when you add them up, they become 0, right? They cancel each other out. So what you do here is you just need to perform the first. And you just need to perform what? The last. Okay. The reason why you didn't do O and other outside the inside is because they cancel each other. So let's look at the first one first. So the first one that we have in this case is 2√2 times 2√2. This is the first one. This times this. So what is 2√2 times 2√2? So 2 times 2 give us 4. Don't forget the root has to multiply. √2 times √2 give us √4. But we know √4 is the same thing as what? 2. So this is actually will give us 8. So the first will give us 8. The last is just 3x times with negative 3x. Don't forget, this side is a negative 3x. So that will give us negative 9x squared. So your answer in this case will be, in green, 8 minus 9x squared. Questions on the 11? Anyone have any questions beside 11 on 9 till 14? 8? 8 is right. Do you mean this question 8? Is that this you're mentioning, Amy? Oh, on 11. Oh, how do I? So what you do here is you take this 2 and then this 2 you multiply, you get 4. And then you take this √2 and √2, you get √4. But square root of 4 is a perfect square of 2. So that's why you get 4 times 2.
So for question 10, then I know you're supposed to break down the root, so that you can get the same root. So then you can like actually add it. Wait, so when you're multiplying roots, you multiply the root as well, but when you're adding them, you don't add the root.
Yep.
Oh, okay.
Yep.
Okay.
So
Got
let's
it.
say you got 7 root 3 plus, let's say 6 root 3. So what you get here? So you just add the number 7 plus 6 is 13. You still get root 3. But when you multiply, then you need to multiply those up. Yep.
Thank you.
Anyone beside? Okay. Let's move on to number 15 and 16. The instruction here is call you to what? Rationalize the denominator. Yes. Yep. You're correct. In this case, Amy, it is 1/4. Make sure you show it to me how you get a quarter. Again, class, I mentioned, right? You have to show me the work because some of your calculators can do this work without doing work. So make sure you know how to show me the works for this kind of questions. Okay, I want to see work. If you just give me 1/4 or you give me the answer without showing the work, you will not get the full points. Okay, I want to see work. Anyone know how to do question 15 or 16, rationalizing your denominator? Anyone need helps with this?
Don't you multiply times the root?
Yep. So if it's a monomial, means one term, you just multiply by the root. If you have a binomial, which is a 2 terms, you multiply by its conjugate. And if you haven't done your homework yet, I will suggest you to do so. Okay, this is all coming from P2. You should be able to do your homework already. Anyone have any questions on 15 and 16? Sorry, I'm trying to move things. All right. How about 17, 18, 19, 20? This is asking you to perform each indicated operation right in a standard form. Standard form means high power to low power. Any questions on 17 till 20?
We just FOIL these, right?
Some of them is void, not everything is void.
Yeah, so the only
can
one
you-
you couldn't foil is 19.
No,
Well,
17 you cannot void.
You just distribute and then combine that, right?
Yes, because they are
Okay.
minus things. So 17 is the one that you cannot void because they are addition and subtraction. 19 is the one that you need to void. Or you kind of like not voiding, you just take x squared and then you distribute. Then 2x you distribute, and then 3 you distribute.
oh, you can only do it like 2 times. Because of that.
Yep.
Okay.
Yep. Make sure you know that this 17 do not void him. Okay. So we will do number 16 here, which is rationalizing the denominator. So 10 over by root 11 over root 6. Since this is a binomial, so in order for us to rationalize this is you have to do the conjugate. And what is the conjugate in this case? It's root 11 plus root 6. And like fraction, if you do the same thing in the denominator, you also have to multiply the same thing to the numerator. Okay. Now, when you do this, you find out that in your denominator, again, when you void the conjugates, you do not need to worry about doing the outside and the inside, is because they will cancel each other off. You just need to do the first and the last. So we have the first, which is root 11 times root 11. So root 11 times root 11 is actually root 121. And 121 is a perfect square of 11. So there is a shortcut here. If you multiply by the roots with the same number, square root with the same number, then you just get that number back. Okay, because this is the same thing as square root of 11 square. And then the square and the square root will cancel. So that's why you get back the same number. And the last one, if you look at the last one, is also the same thing. Negative root 6 with a positive root 6. This will get back just 6. Because 6 and 6 was 36. And square of 36 is a perfect square of 6. Okay. This, it will give us 5. 11 minus 6 is 5. Now for the top one, we just write it down as 10 times root 11 plus root 6. We don't need to multiply, you do not need to distribute in. The reason why we don't need to distribute the 10 in is because you notice that your 5 and the 10 here can be reduced. Okay, so this 5 and 10 can be reduced by 2. So that's the reason why your answer in this case will be 2 times root 11 plus root 6. This is your answer for question number 16. And I suggest you just leave it like this. Don't distribute your 2. You mean you can, I'm not that picky. Just leave it as this will be good enough. Questions with number 16.
Oh, no, 16. No.
Now we go on to 21 till 24. Because 5 and 10, they divide. Brian. Okay. So you got 5 here, you got 10 here. 5 goes in 10 twice, so that's why we get a 2. It's like division. Next question, 21 to 24. Now this question, the instruction call you to do what? Call you to factor. So we begin to factor this. Anyone have any questions on these 4 questions here?
Really quick, I use the AC method for, I think, well, except for 23, I use the AC method for all of them pretty much. I forgot the faster method to do.
Don't forget that the way that you mentioned here is only work for how many terms?
Three terms.
So
yeah.
This is already 4 terms, right?
Yeah.
So 4 terms, you just cut it by half.
Yeah, I did that for that one. Yeah, so I mean, I only did that for 22 and 24.
And then 23, you cannot do it. It's because it only have how many terms? 2 terms. So don't forget the way that you just mentioned, Brian, is only for 3 terms. But don't forget, this is not your first step. What is your first step for factoring?
Just put it in standard form.
Yes. And then what is the second step?
Good question. I kind of just have it down by memory. I forgot.
UCF.
Okay.
And the third step is where you talk about these 3 terms or 2 terms and so on. Okay. So let's talk about question number 22. 2x squared plus 21x plus 10. So my question is this in the standard form?
Yes.
Yes. Do we have a GCF here?
Yes.
What's a GCF here?
Actually, no, we don't. Never mind.
We don't have a GCF. That no numbers can divide 2, 21, and 10. And also the smallest power here is nothing. So that's why there is no GCF here. And this one has how many terms on 22? They have 3 terms, right? But the way that I mentioned is there is the direct factor. This is only when your x squared is nothing, right? Or you have to use the AC method where you have what? X squared is what? Have an A in front or number in front of x squared. So which method are we using for this question 22? The easy method or the AC method?
AC.
This is the AC method. It's because we have a 2 in front. So we have to use the AC method. If there's no 2 in front, then you will do the easy method in this case. Okay.
I guess I was asking for more for like the upcoming questions, like 29 and 30, but we can get to that when we get to that. Sorry about that.
It's fine. So 2 times 10 is 20, right? So you have to give me all the factors for 20, but when you add them, you get what? 21. So the only pair that we work here will be 1 and 20, because 1 plus 20 will give us 21, and then 1 times 20 will give us 20. So what do we do with this AC method is you have to make this become 4 terms, where your 2x squared and your 10 is the same, but this 21x will break into 2, where we will using this pair. So some students ask me is, can I switch your 1 and 20 around? The answer is yes. Doesn't matter, you still get the same answer. The only thing I want to point out to you is make sure you put an X on it. And why we need an X on it is because we are breaking the 21x. So 1x plus 20x gives us a 21x. So that's why you need an X. So students forget to put your X in there, you will get a wrong answer here. And this is 4 terms, so we're going to do groupings here. So what have been common between the first 2 terms? So you can factor out x here, and you will get 2x plus 1. And what is the common? And if you want, you can check your answer by distributing. You will get back the same thing. What are they in common for the second term? Don't forget, this plus sign is important, so the plus sign has to be there. If this is a minus, you have to do a minus sign. And 10 can be divided by this 2. So you will still get 2x plus 10. 2x plus 1. Because this time this is 20x, and this time this will give us 10. And usually when you do what we call as grouping here, these 2 numbers has to be the same. So your answer in this case is 2x plus 1 here, and then x plus 10. And when you guys done, make sure you spend a minute to FOIL it out, because if you FOIL your answer to check your answer is correct, your answer should get back what when you FOIL it? You should get back the original question. If you FOIL here, you didn't get back the original one, means your answer is wrong. That's very easy to check factoring. Questions on factoring?
So it's possible to even get to that point and still have the wrong answer?
Mm-hmm.
Oh,
Because you make a mistake that you didn't see. Yeah, you can make a mistake. Mm-hmm. So if you have time in my test, please FOIL it out to check your answer. 25, 26, 27, this is finding the domain. We just do it just now, like the beginning of the class. What you call 25? What kind of expression we call this? Polynomial, rational, or radical?
polynomial.
Polynomial.
And what is the domain for the polynomial?
All real numbers.
So this is just all real numbers. Yep. How about 26? What kind of expression is this? Polynomials, radicals, or rationals?
Radical.
Yep. So how do we do radical to find domain?
The radical
The
is
radicand.
greater than radicand, I mean, is greater than or equal to 0.
Very good. And then you solve for x.
X.
Do you guys know how to solve for x here?
-5 and
Minus
then
5, so you get negative x. Still the same, greater than or equals to -5. And then what x? What's next?
divided by 1. -1, I mean.
Divide by -1. And what happens when you divide this with a -1?
X equals 5.
We have inequality. What happens to the inequality?
Oh, it flips. It
It
flips.
switch.
Flips.
Very important. You need to know this. So x in this case is what? Less than or equals to
It's +5.
5. Yep, positive 5. Yep. So this is your what? Your domain for question 26. You guys all right?
Yep.
How about 27?
Rational.
Rational. So how do we do rationals? How do we find a domain for the rational expression? Take your denominator and what you do. Make it equals to 0, right? And what is your denominator here? X plus 2, right? Equals to 0. This is your denominator. Solve for x. Subtract 2. So x in this case is what? -2, right? So can someone tell me what is the domain for this question 27? Can you just type x equals to -2?
No, all real numbers except x equals -2.
Yes. All real numbers except x equals to -2. You guys all right? Now let's talk about question number 28. How do we simplify this kind of fractions? Anyone? Anyone know how to simplify these fractions?
Wouldn't you find the GCF of the top? And
We
then
factor them, right? So we have to
you
go through the
them.
factor them, the top and also the bottom, right? You have to factor this. And then after that, you cancel the common factor. And what we call this, we will call this as simplify the rational expression, because it's rational because it's a function. So can someone factor 4x minus 20? So that we have a GCF. Can someone tell me what can we factor out from 4x and 20 negative from and 20?
You can do 4. You can factor out 4.
And you get
X minus 5.
X minus 5. All right, let's do this one. The denominator is a tricky one because, again, we are factoring, so we have to go back to the same rule, right? We have, is this in a standard form? Yes, it is. Do we have a GCF for this fellow?
No.
No, we don't, because there's no number can divide 2, 3, and 18. Okay, so this is 3 terms. So again, back to the 3 terms. Are we using the easy factor or the AC method for this denominator?
AC.
AC.
And the why we choose AC is because we got a number in front. So what is 2 times -18?
-36.
-36. So you need to give me a factor of what times what is -36. When you add up, you get what? The -3x, right? So anyone? What times what is -36? Maybe right. Let's see. 9 times 4 doesn't work, right?
No, I tried this last night and none of the
It's none of
factors
them work. 8 and 8 doesn't work. Okay, that is a typo here. Yep, 6 and 6 also doesn't work, AB. It's a good try, but 6 and 6 doesn't give us -3.
Right.
Okay. I think there's a typo here, Dan. That's no work. So since this is not factorable, because none of this factor is not factorable, so this is prime. So then your answer is just the same thing, 2x squared minus 3x minus 18. Unfortunately, we cannot factor this fellow. And there's nothing can be canceled. So this will be your answer in this case. So weird. I was looking at it too. I was like, Usually I will tell you that there is a pair that goes in there. And when you add and subtract that, they will give you a 3. But this is a weird pair, or this is a weird one. This ones cannot be factorable. We call it prime. None of the 6 doesn't work. 8 doesn't work. 9, 4 doesn't work. What else is good? 3, 12, right? Is the next one.
18, 2, 3, 12, 6, 6, 9, 4, and 36, 1.
Yep, 1 and 36 and 2 and 18. So none of this pair works actually because you will never get 3x. So this is no good. Yeah, maybe I make a mistake on this one when I did this review really late. So so this is your answer in this case, unfortunately, because none of this pair doesn't work in here. Anyone? Questions? How do we do question 29?
Well, first you have to flip the right side, right?
So change it to division, multiplication, the division to multiplication, and you have to flip the second fraction. That is always the first thing when you do. Do you need to find LCD for question number 29? LCDs? Do we need to find it?
No.
Yep. So do not find LCD here. The reason why you do not find LCD is because they are dividing or multiplying. So you do not need to find it. If you're add and subtract, yes, you do. Okay. So first thing we're gonna do what we just mentioned here. We will need to divide to change the divide to a multiplication symbol and flip the fraction, the second fraction. That is the first thing. And what's the next thing we do after you do this? Factor them. So there are 4 of this you have to factor. So let's do the top one here, the first fraction, the top one. What can we factor here?
2.
Yeah, you can take up 2. Yep, that's a GCF. So you get what?
2x minus 3.
That's a factor for him. Now we factor the bottom one. Standard form, already in standard form, and there's no GCF here. And the good thing is the leading coefficient here is 1 or no numbers. So you can direct factor this. You do not need to do the AC method, but if you still want to do the AC method like what we did just now on question 22 and so on, you can, but your step will take a bit longer time than the rest of students who did not do the AC method. So can someone tell me what times what is 1? Is 1 times 1, right? And we need to get a -2. So this has to be what? Negative. So if you use the shortcut method, you just need to write this is x minus 1 and x minus 1. So the 2 pairs that you just found that you multiply, you get a +1, and add, you get a -2. That 2 pairs, you just put it down there with the x in front. This is the easy, that's why we say this is the easy factoring. The reason why I say it's easy is because you do not need to do any crazy work on it. Okay, not do the AC method. Same thing happens in the top one on the second fraction here. This is a standard form and there's no GCF. And this is also an easy factor because there's a 1 in front or no number in front. So you just need to figure out. So can someone tell me what times what is 3? 1 times 3, right? It's a -3. So can someone tell me how you can get a +2 from 1 and 3?
-1 times 3.
So the +3 and the 1 -1. So what is the factor in this case? It'll be x minus 1 and x plus 3. And for the last one, which is this fellow, 2x squared minus 3x. Can someone tell me what can be factor here?
X.
So you can factor out x as a GCF, and what you get when you factor x out from this 2, you will get 2x minus 3. That's for the last one. And I think you know what to do. The next step is to cancel the common factor. So the 2x minus 3 can be canceled. One of the x minus 1 can be canceled. The leftovers cannot cancel, right? So this is your answer here. So 2 times x plus 3, that's the one on the top. And then the one in the bottom is x times x minus 1. Again, you can move them around. I'm not picky here. Please do not distribute this or FOIL it out. Just leave your answer in a factor form. How do we get rid of the x after 3? Which x you talking about? The last one? Because they are having the common factor, so we can factor the x out. So, so x times 2x will give us 2x squared, and then x times negative 3 will give us negative 3x. So it's kind of like just a GCF in this case. How about number 30? Do you need to find LCD for question 30? Yes, and why we need to find LCD for question 30 is because question 30 you need to what? Add and subtract them, right? And don't forget, class, this is being recorded and I will upload into YouTube. You can watch it. I will give you the link in D2L. Please watch it, you know. And so question 30, yes, you had to find LCD here. So before you find LCD, you have to factor this. So go ahead and factor your denominator. What is x squared plus 8x plus 12? And also factor what is x squared plus 9x plus 18. Now, the good news is both of these are trinomials, 3 terms. They are all having 1 in front. So there's no, it's already in a standard form and there's no GCF here. So what times what is 12?
6 times 2.
Okay, so we do x plus 6 and x plus 2. Because when you multiply this, you get 12. And when you add this, you get 8. Again, I'm going to give you small number like this in your test. I won't give you like 100 something. No. I'll give you small because I'm testing you on a small number here. All right. This is also the same thing, 18. So can someone tell me what times what is 18? But when you add them, you get 9.
3 and 6.
So it's x plus 6 and also x plus 3. Okay. This is called fast factoring, and make sure you guys know how to do this. Very important. Now we're going to find LCD here because LCD is, we are adding and subtracting here. So in order for find LCD, these two are common. So x plus 6 is common. So we only write it down as 1 time. This is a common piece. The one that is leftovers, you just put it down on the LCD. So the x plus 2 and the x plus 3 is the leftovers. So we just leave it in the LCD like this. So this is your LCD here. Your LCD in this case will be x plus 6, x plus 2, and x plus 3. Now, what is missing? If you look at the first fraction, what is missing if you compare to LCD here? You are missing x plus 3. So we will be multiplying x plus 3 here. And what you need to do here also has to multiply to the top. Now, what is missing on the second fraction? If you look at the second rational expression, when you look at the LCD, you find out that x plus 2 is missing. So you will have to multiply x plus 2 on top and the bottom, both of them. So this is like adding or subtract fraction. As long as your denominator is the same, then we can add, subtract your numerator. Now the good news is the denominator here is the same, which is the same as your LCD, x plus 6, x plus 2, and x plus 3. So as long as they are the denominator same, then we can combine, we can add and subtract the top. So let's distribute the 4. So you will end up with the 4x plus 12. Now this is a tricky part over here is you don't distribute the 3. The reason why you don't distribute 3 is because of the negative. So actually you need to distribute the negative 3. This is a students make the most mistakes here in my test. So you will subtract 3x and then minus 6. Okay. So this is something that students tends to make mistake here is make sure you distribute the negative, not the 3, but negative 3 in this case. So combine like terms. So 4x take away 3x is x. 12 take away 6 is positive 6, right? And then you still have the same thing as your LCD. X plus 6, x plus 2, and x plus 3. Now, the good news is we can simplify this. So which one can be canceled here?
X plus 3. Wait, x plus 6.
Yep, we can cancel the x plus 6. So what you left here is 1 over, because once you cancel the top one and you got nothing left, you don't get 0, you get 1. Okay. And the denominator here is just x plus 2 and x plus 3. So this is your answer for question number 30. You will get 1 over x plus 2 times x plus 3. Again, leave your answer as fraction, as factor form, means do not FOIL this or distribute this. Okay, don't spend your time doing it. So this is how we do question number 30. Questions? And the last one we're going to do is question number 31. This is the last question. And this question 31 is a complex fraction, which you learn in my class today. So in order for us to do question number 31 here, you have to find the LCD on the top and you have to find the LCD on the bottom. So let's do the top one first, the numerator, LCD. Now this one is over 1. So anyone know what's the LCD on the top part here? That LCD will be x. So we will have x here. So this, you will multiply this by x. This one stays the same. So what you get here is x plus 5. You do the same thing in the denominator. This is also over 1. So what is the LCD in your denominator?
X plus 4.
X plus 4, yeah. So this will be x plus 4. So this, you need to multiply x plus 4 here to make it the same as the denominator. This one is the same, we didn't do anything. So let's distribute the 1. So 1 times x will become x. 1 times 4 is 4. And don't forget, you still have a plus 1 on that side. So if you combine like terms, this is actually is x plus 5 over x plus 4. And we're gonna divide this with your numerator of x plus 5 and x over x. Now, how do we divide this? Anyone? The numerator stays.
Yeah, you switch them and turn into multiplication.
Yep. So
yeah.
And then flip flop this below. So it's x plus 4 over by x plus 5. Yep. None of this can be factored. It's already been factored completely. So what can we cancel? The x plus 5 can be canceled because they are the common factor. So what is your answer here?
x plus 4 over x.
That's it. And don't forget, this is called complex fraction. And this is how we simplify the complex fraction. Questions, anyone?
Can I see some of, oh, now I can see it. Sorry,
You're fine. Again, this is all being recorded. I will send you all this page. This one I written down today. Every single pages will be posted in D2L. So please go to D2L or check your college email because I will send all this to you. It will take me some time to upload and download this to YouTube, okay? Because I have to upload it from Zoom and then download this whole video to Zoom. So it will take me around like 30 minutes to do that. So just be patient with me, okay? So anyone have any questions with the midterm?
Not the midterm, but just one more question on the review. Question 3 all the way back. Is that -2 outside of the whole equation?
Yes.
Is that a exponent?
Yes.
Okay.
The whole thing to the -2 exponents. Yep.
Okay, so you distribute that first, and then you go ahead and
you can distribute the whole thing -2, or you can switch it.
You can switch it off first, or
so as you know that this negative, you switch things around. So we have a rule says that if you have a negative exponent, you can get rid of a negative by just flip-flop the fractions. You can do that.
Okay.
And then you distribute the n in there, so you come bn over here. Try this on your own. I really want to try it because I don't want to do this for off, you know, because if this is coming in your test, there's no help button. You guys with me here?
Right.
Yep. So I really want you to try number 3. So you can do that, or you can distribute the negative. You can do it. But then you just need to change it back to positive by switch them back around. You still get back the same thing. So it's not right, wrong, Ryan, when you do that. And there are 20, Abdurrahman, there are 20 questions in your midterm.
And basically you just be adding those to the other exponents inside the parentheses, right? Okay. If you
distribute, and make sure you know that the 2 here is a power 1. Just want to tell you that the 2 there is exponents is 1.
Makes sense.
Questions? Try to do the rest of the midterm because I did almost half of it, right? So try to do the rest of it. Anyone have any questions with your homework, P3, P4, P5 that is due tomorrow? I would recommend you to do tonight because these are coming up in your midterms tomorrow. Anyone have any questions?
You said that we're going to be able to see that 31, right?
I'm sorry. What do you say, Zakarim? Sorry, I cannot hear you.
Hold on. Trying to fix this. You said I'll be able to see that number 31, right?
This is 31. Yeah.
I don't know. Something.
What do you mean you can see 31?
There it is. Now I can see it.
This will be posted in D2L.
Practice it. Oh, this will be in D2L.
Oh yeah, everything will be posted in D2L. I will post. That's why I'm saving all this into my file here. So it will. This is called review midterm page 5.
Okay.
This is the last page. Yep. So review midterm page 1, 2, 3, 4, 5. This all been saved. So it will be posted in D2L. Also, it will be posted. It will be sent to you via email. Every single thing that we did today in class will be in there. Anyone have any questions on the homework?
Homework. Oh, so P5 is also. Oh, I didn't know that was. I didn't realize that was due. Okay, I'll do that right now. I already did the bonus.
Yeah, as I mentioned, right, the review of the midterm is the one that you have to concentrate on, right?
Yeah, I finished that a few days ago.
Because yeah, this is gonna give you 10 points to your extra credit to your midterm, right? So make sure you do this. This is very important. Make sure you have your name on the class. Make sure you have your name. This is a 10 extra credit points going towards your test. So that is like a miracle. This is something that will push your F to a D or a C to a B because of this midterm. Just want to tell you that. big points here. Okay. Then your homework. So make sure you do this too. So anyone have any questions if I get going here? And don't forget, tomorrow we still have time for review. So that's why okay, if there's no questions, you may leave the class. If you have any questions, stay back. Okay.
So, oh, sorry, my mom showed up, so that's why I kept.
Yep. It's all gonna be posted in D2L, so don't worry about Karim. Don't worry about catching up with this because you will be see all these notes in D2L. Anyone have any questions for me before we get going here?
Yeah, so if we don't get all that homework done today, are we just going to be behind and we can still do it for credit, or does it disappear?
If you did some homework already, it will have that part. I mean, if you just finish 50% of it, you will still get 50% of the homework point. You know what I'm saying here, Brian?
Yeah.
I did, as I mentioned, you can either ask for extension, or I also will drop one of the lowest homework score.
Okay. So yeah, if we just do it late, it disappears, but we can still ask for an extension if need be.
Yep. But
okay,
I will suggest you to do it because the three set P1, P3, P4, P5 will be in your midterm. So that's why.
Right.
Yep. So it's a good practice.
Got it. Thank you.
Mm-hmm. Anyone questions?
My last one is on there where it says find the domain of the expression.
Mm-hmm.
I saw one that had that slash through the equal sign.
Which one you're talking about, Kareem?
If you go down, not 25 or I can't see it on my, what do you call it?
25 on your
on the P5.
P5.
Yes.
Sorry.
I think it is
25.
Yes. Once you put it on your screen, I'll be able to see it.
So this one?
No, I guess it wasn't 25.
Mm.
Can you go up? Because I can't see it on mine for some reason. No, it was the ones that are just like this, where it says find the domain, except it had like a slash through the equal sign. What is that?
Not
mean?
equal to.
Okay, so that is not equal to.
Yep, like this symbol.
There. Yes.
This is not equal to.
So all real numbers, x such
that x is not equal to. This is the same thing as x except x. So it's like an English word here. So except, I like to use the word all real numbers, ARN, I just short form everything. All real numbers except, I say x equals to 5, right? Example, right?
Okay.
Also, you can use the word all real numbers such that x is not equal to 5. These two are the same thing. They're the same.
Oh, okay.
The word except means you cannot have it, which is the same as not equal to. Mm-hmm.
Got it.
They are the same. Yeah. This except x equals to 5 and x not equals to 5. Potato. Same. Don't worry about that.
Okay. All right.
I take this, I take this. You know, they are the same.
Okay.
Mm-hmm.
Thank you.
What else? Any questions, students? So this is what will be, if you have any questions you want to Zoom, I can Zoom with you guys. If you're not, if you need a one-on-one help, something else, send me an email to set up Zoom so I can, if I'm free, I will definitely Zoom with you. Any questions before we end the Zoom? I need to talk to Malik.
That's it for me. Thank you.
Okay, you may leave. You have no questions. Malik, I need you to go into the room 1 there. Just Malik. The rest, any questions?
No, thank you very much.
Yeah.
I'm all good. Thank you.
Yep, Victor, Kareem. If you have, just stay on and let me talk to Malik in Zoom 1 and then I'll be back. You got that, Malik? Okay. So I think you know your test is going to be in a testing center, right?
Yeah.
Yep. So you can take your test anytime you want, but make sure you come back at 2:10 to the classroom.
For the 10-minute talk.
Yes. I already put a note, everything in there already. They know about it. I did this before the COVID. Mostly before COVID, I give students do that. I also you just need to go in there, sign up using your name, and then bring my name out, David Liu, and then they were able to get the test out for you.
All right.
And we have a class from 1 o'clock to 1:30 to review. So if you want to attend that,
Yeah, I'm going to attend that.
and then at 1:30 till 2:10, you will be you got 2.5 hours. So I assume if you start your test at 1:30, you should be done by 4 o'clock.
All right.
So do you have time from till 4 o'clock tomorrow?
Yeah, I do. Yeah, I do.
Okay, good. So then you take it then at 1:30 till 2:10, then 2:10 to 2:20, you come back to class to do the talk. If you want to leave like a couple minutes early because it's a big walk from the testing center, you know what I'm saying?
Mm-hmm.
And then after that, you reach to my class, we do the talk time, and then at 2:20, you leave, and then you go back. You got another hour-ish till 4 o'clock to finish your test.
All right.
Does that sound good to you?
Yep. And when I'm done with it, do I just come back to your class and
Nope,
give it to
you're
you,
done.
or
You're done. If you're done, and if you're done early, you're done early.
do I just give it to someone at the
Give it to the
testing
testing center people.
Right.
Yep, you do not need to come back and do anything. You just give the test back to them, and then you're done.
All right. So what I plan tomorrow is after my biology class in the morning, I'm going to go find Dale to work at the math center just to review over stuff to get more comfortable later on. And that 1 until 1:30.
Can you double check if they're having a in person, or are they gonna have it via Zoom?
I think it's gonna be in person.
Okay, I know Zoom for sure, but double check because I didn't know they changed it back in person this semester. Because last few semester is all Zoom via Zoom. So go into the library. You know where is it here, right?
Yeah, I do know where it is.
Okay, so go in the library and check. If it's not in there, then you will probably have to set up the Zoom.
All right.
Okay, and yep, and then then you come to class at 1 o'clock. We'll do the review till 1:30, and then the whole thing.
All right, gotcha. Right.
Any questions you have for me, Malik?
No, not so far. For now, for me, it's just I gotta do P4 and 5 so far right now.
So try your best to catch up with P4 is factoring, which is very important. I would recommend you to try your best to finish P4 tonight. And then P5, do a little bit, try push it hard, and then I can open once if you have like 1 or 2 sections. I will hoping you finish P4 tonight, and then maybe I'll open up P5 for you. You know what I'm saying?
Gotcha.
Yep. Try your
So
best.
focus on P4 more.
Because it's factoring, and P5 needs P4, so that's the one that you need to concentrate on.
Okay, gotcha.
Yep.
All right, then. Well, thank you.
Yep. Any questions beside?
No, I don't have any other
And
questions.
also, this is very similar to your finals, and which is like something like this, same kind of schedule. And then if you're taking college algebra, it will be very similar, except for I don't think so. I have a top time. I need to think about what should I need to give it to you guys in college algebra.
Well, for me, after this class, I think spring semester, the next one actually, I'm just gonna go to pre-college, and then winter I'll be doing college algebra. That's my plan.
Oh, why you think this is actually the same as pre-college algebra?
Oh, is it?
This is the one that getting you to college algebra.
All right. Well, I'm just still reviewing over a few things.
So we'll see. I always tell my students we'll see what happens on this test, the midterm for this test, because it will reveal something for me. So if you think this is too fast, then you go to pre-college algebra.
Right. Gotcha.
That one is a slower, like 10 times slower pace than this one.
Right. And then you also said we're allowed to have one front page side of a sheet with methods.
Yep. It's also written down on the testing center, so you just make sure you have that with you.
All right.
I think you have to turn that in after that. Once you finish the test, just turn in that one page note in there.
Oh, gotcha.
Yep.
Right.
All right.
Well,
And
thank you for the Zoom
Yep.
meeting today. Kind of
Yep.
helped out a bit.
Yep. Hopefully. Yep. Next. Hopefully, I will do more about this if if you need help or something else, that
All right. Well, thank you very much.
Okay. You take care there.
You have a nice day.
Bye bye.